Hi everybody, when looking at algebra, we want to start by thinking about what this means. So this here is an equal sign, and it means that it's the same as something else. So basically in maths we use symbols, and the symbol here means the same. So for example, I could take something like this, 4 equals 4. So what we have here on the left hand side is the same number as what we have on the right hand side. So that's true, because we've got the same number. Now, there are certain conditions around which we can work with this equation. So this is an equation because it involves an equal sign. So we've got the same number on both sides, but what I can do is I can do the same operation with the same number to both sides. So I can add 1 to both sides, which tells me that 5 is equal to 5, and this is still true because it's the same number. It's a different number, but it's a different number to what we had before, but it's the same number on both sides, so it's still true. Or I could take this and multiply both by 2. Multiply both sides, so I get 10 equals 10, so this is still true, as it's the same number on both sides. Or I could do another operation. I could take 2 on both sides, which gives me that 8 is equal to 8, and so this again is still true as well. Now I can also, I've got my last operation, I can divide both sides by the same number, and it's still going to be true. It's going to have the same number on both sides, so it's still true. So I can say that making both sides operated on with the same number in the same way keeps the equation true. Okay, so when we're thinking about algebra though, we're mainly thinking about something that represents a number. So a variable, we saw last time or when we did algebra, a variable is a letter which represents a number. So if we take a variable we commonly use, say for x, we can say that x represents 4 as an example. So what I can say is that I can say x is equal to 4. X and 4 are the same thing. X is representing 4, so it is the same thing as 4. Now what I can do, which is still going to make my equation true, it's going to be the same thing on both sides, is I can both multiply both sides by 2. So I can say that 2 times x is equal to 2 times 4. Now we know that 2 times x can be written as 2x, and we know that 4 times 2 is 8. So I can say that 2x is equal to 8. So 2 times x and 8 are the same thing. Then I can add 5 to both sides. So I can go 2x plus 5 is equal to 8 plus 5. So 2x plus 5 is equal to 13. 13 and 2x plus 5 are the same thing. So they're the same. Now if we want to think why is that true, well remember we said x is 4. So if I go 2 times 4 plus 5, well how do I do this? Well I do it via BEDMAS. So BEDMAS says as I work my way down, I look at brackets where there's no brackets, I look at powers or exponents, there's none of that. Is there any division? Well there's no division, but there's multiplication. So I've got to do my multiplication first. So this is going to come first, and then I've got addition, so this is going to come second. So I do my multiplication first. So I do 2 times 4, which gives me 8, and then to that I add 5, and so 8 plus 5 gives me 13. So we see that if x is 4, then 2 times x plus 5 is the same, or is 13. Okay, alright. Now, what I want you to do is I want you to build up some equations like I've done here, and then check that they work, that you get the same thing. So in the next screen, you'll be asked to build up an equation, and then you'll go from there. And I'll have the answers after you've done each question. So the first question that we had, and I'll do 1, was we were told that x equals 5, and we were asked to multiply by 2, and then add 3. So I can go 2 times x is equal to 2 times 5, so 2x is equal to 10, so double x is the same as 10, and then I can add 3. So 2x plus 3 is equal to 10 plus 3. We've got to do it on both sides to make sure this all stays the same. And so then 2x plus 3 is the same as 13. Now, is that true? Well, it was for x equals 5, so 2 times 5 plus 3. I'm going to do my multiplication first. So it's going to give me 10 plus 3. Then I'm going to do my addition. So it's going to give me 13. So that's true. Okay, the next one, well, was to start with x equals 3, and we were to multiply by 6 and then subtract 13. So x is the same as 3, so now I'm going to go 6 times x must be the same as 6 times 3. So 6x is equal to 18. And then 6x take 13 is going to be the same as 18 take 13, which is 5. So 6x take 13 is the same as 5. Now, is this valid? Well, we did this for x equals 3. So it was 6 times 3, take 13. Do my multiplication first to give me 18. Take 13. And then if I do that, I get 5. Okay, our next one, we start with x is equal to minus 2. And then we're going to multiply by 10 and then add 5. So x is the same as minus 2, which means that 10 times x will be the same as 10 times minus 2. So 10x will be the same as minus 20. And then 10x add 5 will be the same as minus 20 add 5. So 10x add 5 is the same as minus 15. Now, is that true? Well, we were saying that this is when x is minus 2. So 10 times minus 2 add 5. Do my multiplication first. So this is minus 20 add 5, which gives me minus 15. However, what happens in a lot of cases is we won't get told what x is the same as, but we've got to find that. But we'll be told some information from the equation end. So for example, what I mean by that is we'll be told that 3x plus 6 is 27. So 3 times x plus 6 is 27. That's the same as 27. So we want to know what x is. Now in this case, it's important that we solve it in the right way. Now what we could do is we could just put numbers in and keep going until we actually find when 3 times a number plus 6 gives me 27, but that's pretty long-winded, and if we want to do that with more complicated equations, it's going to take a long time. So instead we want to do a set process. Now, we want to find what x is the same as, and we know that 3 times x plus 6 gives me 27. So, in this equation we can say that if I have x, if I start off with x, then I can see that I'd first multiply it by 3, and then I'd add 6, and that gives me 27. Now what that means is, if I take 6 from both sides, if I do the opposite to adding 6, then I'll get what 3 times x is. And then if I divide by 3, I do the opposite to this operation here, then it'll actually just tell me what x is. So I kind of undo it by doing what we call reverse bedmass. So I go back the opposite way to the way I built it up. So if I was building it up by bedmass, I'd multiply by 3 and then add 6. If I was going back the other way, I'd take 6 and then divide by 3, and that should give me x. Let's see how that works. So if I have 3x plus 6 equals 27, what I can do is I can do the same thing to both sides. Remember, I can always do the same operation with the same number to both sides, and it will keep everything the same. So I can go 3x plus 6 take 6, so I can take 6 from both sides and it will keep things the same. Here I'm adding 6 and taking 6, so that'll just give me 0. So that kind of cancels out in a way. So then we have 3x is equal to 27 take 6, which is 21. And so 3x is the same as 21, and then I can divide both sides by 3. Because I've got a common factor of 3 in the top and the bottom, I can cancel it out. And so I get x is equal to 7. So we see that x is the same as 7. So what's the process to do these? Well, first of all, by bedmass, we explain how it's built up. So we start with x, we multiply by 3, we add 6. Then from that, we work out the reverse process that we're going to have to do to undo this equation to find what is the same as x. So, for the next two equations, you'll be given some equations which I want you to go through and solve. I want you to start by saying how it's built up, and then go through and explain the process that we need to undo it, and then I want you to use that process to find the answer, and then I'll do it in here. Okay, alright, so our first example is 5x take 17 is equal to 3. So here, if we start with x, we multiply by 5 and then we subtract 17. So if I want to undo this, I'm going to have to add 17, then divide by 5, and that's going to give me x. So 5x take is 17, that's the same as 3. So then I'm going to add 17 to both sides, and that means I'm going to get something that's the same. So those 17s are going to cancel, so then 5x is going to be the same as 20. Then to work out what x is the same as, I can go through and divide by 5. So if I divide both sides by 5, those 5's cancel as common factors, so x is the same as 4. Now, our second example told us that 15x take 5 was the same as 55. So in this case, x is being multiplied by 15, and then 5 is being subtracted from that. So if I want to undo this, I'm going to have to add 5 and then divide by 15, and that's going to give me x. So 15x take 5, and I'm going to add 5 to both sides because it's going to keep everything the same. Those 5's are going to cancel, so I get that 15x is the same as 60. Then I'm going to divide both sides by 15, not minus 15, and divide that side by 15. So the 15's there as common factors are going to cancel, and 60 divided by 15 gives me 4. So x is going to be equal to 4. So x is the same as 4. Now, there's some examples. I'm going to write some examples down, and I want you to go through, use the same process, and then see if you can get the answers. Okay, so here you're given 9 equations with the answers. Now, the answers aren't the important bit. The important bit is going through the process so you can actually show that those are the answers. So I want you to pause this video now, and I want you to go through and do these 9 questions, and then once you've done them and been able to get the answer, then come back and we'll keep going. Not every equation is going to look like the ones we had up above. See, for example, here I can have a different equation. I can have x over 2, x divided by 2 plus 5 equals 14. But the idea and the process that we go through is the same. So we start with x. If we're building up this left side, if x was a number, BEDMAS would first tell us to divide by 2. So the very first thing is we divide by 2. You see, it all depends, when we're building it up, it all depends on what BEDMAS says. And BEDMAS says we first divide by 2, then we add 5. So if I'm trying to undo it, I'm going to take 5, multiply by 2, and that's going to give me x. So let's have a look at how that works. So x over 2 plus 5 is equal to 14. First thing I do, because I'm undoing it now, is it's going to be take 5. So it's going to be x on 2, and then I'm going to take 5 from both sides. So it's going to be keeping everything the same. And then 14 take 5 gives me 9. So x divided by 2 is 9. So x divided by 2 is the same as 9. And then I can multiply by 2 to find what x is. So x divided by 2 multiplied by 2 gives me 9 times 2. So I'm not changing anything. I'm keeping everything the same. Those 2's cancel there. And so I get x equals 18. So x is the same as 18. Now there's going to be a couple of examples here that I'm going to get you to have a go. Build up the process. Remember that we divide first, then multiply, and then that will give you the exact process in the reverse order to undo it. Okay, now, not every equation is going to look like the ones we had, but so we're going to do some examples of that. So x on 2 plus 5 equaled 14 gave us x equals 18. But the other example, the next example we did is x on 4 plus 5 equals 1. So here you've had to go at the process yourself. So if we start with x, first thing we're going to do is divide by 4, and then we're going to add 5. So to undo this, we're going to take 5, multiply by 4, and that should give us what x is equal to. So I've got x on 4 plus 5 is equal to 1. First thing I do is subtract by 5, so it's x on 4 plus 5 take 5 is equal to 1 take 5. Now these 5's are going to cancel, so it's going to be x on 4 is equal to minus 4. Now, so x divided by 4 is the same as minus 4, and then we're going to multiply both sides by 4. So we're going to times 4 on both sides, keeping everything the same. So that 4 there is going to cancel. So x is the same as minus 16. Now in our second example, we had x on 7, or second problem to work through. We had x on 7 take 8 equals 692. It looks daunting because of all the numbers that we've got there, but it's the same process. So what we did is we started with x, we divide by 7, and then we take 8. So if I'm going to undo this, I'm going to have to add 8 and multiply by 7. So this is equal to x. So if I've got x on 7 take 8, then I'm going to add 8 to this side, and it's going to give me 692 plus 8. So 8's there are going to cancel, so we get that x divided by 7 is the same as this is 700. And so then I'm going to multiply by 7, so x on 7 times by 7 is equal to 700 times 7. So then if I cancel the 7's, I'm going to get x is the same as 4,900. And it seems like a really big number, so it seems wrong, but it's not. We can have big numbers. Remember that x can represent any number. It could be a fraction, it could be a decimal, it could be a big number, it could be a small number, it could be a whole number, it could even be not a whole number. So it can be anything and it can still be right. So don't fall into the trap of thinking that seems wrong, as long as you're sure of the process. Okay, alright, so in this next one, it's slightly different again. So we've got x, but we've got minus x. Now minus x can be thought of as minus 1x, so it can be thought of as minus 1 times x. So the first thing that we're doing to x is we're multiplying it by minus 1. And then we're dividing by 11, and then we're subtracting 1. So if I want to undo this, I'm going to have to add 1, I'm going to have to multiply by 11, and then I'm going to have to divide by minus 1, and that's going to give me x. So minus x on 11 take 1 is equal to 8. So the first thing I do is add 1, so minus x on 11 take 1 plus 1 is equal to 8 plus 1. So I'm not going to change anything, it's still going to be the same on both sides because I'm adding 1 to both sides. So minus x on 11 is equal to 9. So then minus x on 11, I'm going to multiply by 11 both sides. It's going to keep everything the same. The 11s are going to cancel there. So I get minus x is equal to 99. And then I divide through by minus 1. That's minus 1 out the front there, so it's going to cancel with the minus 1 there. So x is equal to minus 99. Okay, now I've got some more questions like this that I want you to practice. And so I'll put them up on the screen with their answers so that you can know that whether you're getting them right or not. Now, for our last section in today's lesson, we're going to do ones where it's swapped around a little bit and it's going to look a bit different and potentially look a little harder, but we're just going to have to step our way through it and think about it carefully. So, but before I get there, what I'm going to do is I'm going to introduce a really important concept. And so if I draw a little figure, he's going to introduce the concept to us. So he's got a nose, and these are his two eyes, and this is his mouth, and we'll give him some hair as well. We can call him Spike. And what he's going to tell us is that the sign in front goes with the term, So, what that means is, if I give an equation, 4 take 2x equals 2, this minus goes with the 2x and has nothing to do with the 4. So, minus goes with the 2x, has nothing to do with the 4. So what sign is in front of the 4? Well, if there's no sign, then it's a plus. So we've got plus 4 take 2x equals 2. Now, if we think about this carefully, how is this built up? Well, if we start with x, we can multiply by minus 2. That's because our minus is part of our 2x, so we're multiplying by minus 2, and then we're adding 4. So if I want to undo this to find what x is, I take 4 first, I divide by minus 2, and that's going to give me x. So let's go through and do that. So we've got 4 take 2x equals 2. So it'll be 4 take 2x equals 2. So those 4's are going to cancel out, but the minus stays with the 2x because the minus is associated with the 2x and not with the 4. So messing around with taking 4 does not affect this minus. It will stay there. So minus 2x is equal to 2, so I divide by minus 2, both sides. The minus 2's will cancel there because it's a common factor, and x is equal to minus 1. Okay, right, so we're going to do some examples of this. Okay, so in our first example, we have 3 plus 2x equals 13. So the way this one's been built up, we've got x, we're multiplying it by 2, and then we're adding 3. So if I want to undo this to find what x is, I take 3, I divide by 2, and I get x. So 3 plus 2x equals 13. First thing to undo this is we take 3. Take 3 there, and on the other side as well to keep everything the same. So those 3's cancel out. Got a positive here, that stays with the 2x, so it's going to be 2x equals 10. Then I divide both sides by 2. Those 2's cancel there, so x is equal to 5. Okay, in the second one, we have minus 4 take 3x is equal to 17. Now the way this is being built up is we've started off with x, we're multiplying it by minus 3, because this minus goes with the 3x. So we're multiplying it by minus 3, and then we're taking 4. So to undo this, I'm going to have to add 4, divide by minus 3, and that's going to give me x. So minus 4x, or rather not 4x, minus 4 take 3x equals 17. To keep everything the same and start to undo, I'm going to add 4 to both sides. So that's going to cancel out there, but the minus is going to stay with the 3x because it's part of that term. So minus 3x is going to equal 21. So I divide both sides by minus 3. It cancels out as a common factor, so x is equal to minus 7. Okay. In our third example, it's slightly different. We have 7 take x on 6 is equal to 5. So in this case, x is first being divided by 6. Well, first of all, actually, it's minus x. So it's first of all being multiplied by minus 1, then it's being divided by 6, then we are adding 7. Remember, the sign in front goes with the term, and if there is no sign, then it's a plus. So to undo this, we're going to have to take 7, we're going to have to multiply by 6, and then we're going to have to divide by minus 1, and that's going to give us x. So, okay, let's go through and do this. So 7 take x on 6 is equal to 5. First thing we take 7, so 7 take x on 6 is equal to 5 take 7. So those 7's are going to cancel out, but the minus is going to stay with this term because it's part of that term. So 5 take 7 gives us minus 2. Then we're going to multiply both sides by 6. So times by 6 there and times by 6 there, keeping everything the same. So we'll get that minus x is the same as minus 12, and then if I divide through by minus 1, we can think of that as minus 1 out the front of the x, so those will cancel, so x is equal to 12. In our last example, we have minus 2 plus x on 3 equals 1. So in this case, x is being divided by 3, and then 2 is being subtracted, so we're going to have to add 2 multiplied by 3, and that's going to give us x. So in this case, minus 2 plus x on 3 is equal to 1. The sign in front goes with the term, so this is going to be plus 2. But don't worry about the plus there because that's part of the x on 3. So it's going to be plus 2 x on 3 equals 1 plus 2. That's going to cancel out, giving me x on 3 is equal to 3. So then I multiply by 3, so it's x on 3 times by 3 is equal to 3 times 3. That cancels the 3's there, and so x is equal to 9. Okay, so here's 5 questions. You've got the equations and then the answers. But remember, the main process is to go through and find the answers using the process that we've done in class. And that's the end of this lesson.